Hello, my joshful, energetic students. How are you? So full josh ke saath you're preparing for NSEP exam. So I'm back with my Noodle Chopstick series, and we know what this series is about. Basically, it's about whenever you are faced with a challenge in life, maybe or some question in your academics, there are two ways to solve it. One is go fancy noodle way, or another one is go simplicity like chopstick. So noodle chopstick. I prefer chopstick. Some people prefer noodle. I don't know why. And basically, the noodle method is definitely very confusing, lengthy, error prone, and difficult to grasp. But still, some teachers prefer that. And I always think it might be because as a student, they learned it that way, and maybe they do not know that there is a better option out there. Or maybe they know it and they want to portray the topic as a rocket science. Either way, we are going to stick to our chopstick method where we'll go a simple route to understand a concept here. So my name is Bhavdeep Sethi. I've been converting a lot of physics haters into physics lovers. And I always say physics ko ratta maroge to physics bura maan jayegi. And you go out in the nature and you study physics out there. So today basically we are going to talk about what is first of all RMS value, and then what is the logic behind saying RMS value is the peak value divided by root 2. This image is coming from Wikipedia, but this is the formula that many students memorize. So what is RMS first of all? What is RMS? So root mean square. So let's say I have some numbers. Let's take some numbers. Let's say number 2, then I have a number 5 maybe, then I have number 7 and number 20. Let's say I have some numbers out there, some randomly written numbers. There's no logic. Don't try to find any pattern over there. This is not a mental ability series kind of thing. It's just some numbers written there. And I want to find the mean. So how would you find the mean? Mean would be found, mean as an average is equal to the sum of these values, and then you divide by the number of items over there. That's mean. I mean, that's average, right? But then what is RMS? RMS stands for root. Let's write it out. Root mean square. So basically you take the square root of the mean of the square. Root means square value. Root means square. Root of the mean of the square. So RMS value for these same numbers will be root. Root of what? Root of the mean. Mean of what? Mean of square. So first you square these numbers. You square these numbers. You square these numbers. And then you take the mean of these numbers. You take the mean of the squares. You don't take the mean of the numbers. You take the mean of the squares. Items are still 4. Remember, the items are still 4. You have taken the square of all those 4 numbers. You added them up, divided by 4 because there were 4 items. And then you take the square root of that. So root mean square. RMS is root mean square. And that's what it is. Now, there's a little interesting story here. I'll put down the pen and just take a couple of minutes of this. There's a little story that I would like to share with you. So, when in my schools I learned this root mean square, I was really amazed. I was like, wow, this is so boring and this is so fancy. And I was really falling in love with this. And I thought, yeah, that's really looking nice. And what happened is I was good in math. So, and I'm talking of back in days when there were no computers, no spreadsheets, no digital data. So we used to maintain the records on these paper and pen. So my teacher, she was maintaining the marks of the students in a register, and I was good with maths. So she gave me the responsibility. Bhavdeep beta, you find the average of marks of section A versus section B versus section C so that we can compare how the class is performing. So I was given the duty, and remember, there were no calculators either. So we didn't have the luxury of calculators also. I'm talking about back in old days. So I was supposed to write down the numbers, add them up, divide, and so forth. So she gave me the responsibility, thinking I'm very good with maths. But then the previous week itself, I had learned this amazing tool, and I was like, okay, ma'am asked me to find the mean of those numbers. That's so boring. Maybe it's old fashioned. Let me find RMS, root mean square. And I actually did think about the time and effort and energy I spent there. 50 students in each of those sections. So I'm squaring the marks of each of those, adding, dividing, square root, think of taking a square root. And I found it and I was so happy, and I took that notebook to register to my teacher. Ma'am, I have found this. First of all, she was English subject teacher and she was like, what is all this? And I was scolded, I was punished. And needless to say, I never got that volunteer opportunity again because. And then I went to my physics teacher and I said, "Sir, I'm really confused here. Like if I'm taught this, why can't I use it?" And the answer I got was, okay, when you have to find the average of marks, you use this. But if you have to talk about electric current, you use this. And my question was, why? And I got a scolding again. I mean, why do you ask so many questions? Are you Einstein? Are you Newton? I mean, I was demotivated in asking those questions. And think about it, isn't it a valid question? As a curious kid, wouldn't I be curious? Why are you telling me if I have to find the average of marks, I use this? But in current electricity, don't use this, use this. Why? And that was one of the reasons, not just the only reason, but many such incidents that happened in my life when I thought, okay, no, I have to become a teacher and I have to give the logic behind all this and I have to encourage students asking me these questions. So today, let's see why in electricity we are using this. So let's first do that. So let's see what are we talking about. So let us say you have a circuit and you plug in a voltage to that. So resistor voltage, Ohm's law says the current is voltage by resistance. Makes sense. But what if the voltage is fluctuating? What if the current is fluctuating? Right. So I know, let's take an example. So let's say there is a resistor here, and if the current flows through that, I know how much, and the resistance is R. I know the power is I square R. I know that part, right? But what if the case is when the power is changing? So let's look at this way. So I have so in this case, let's say I have a circuit where time versus current is fluctuating. I'm not talking about alternating current or whatever right now. I'm making it simple. I'm just saying some fluctuating current. So there is I1 current here, which changes to, after some time, it changes to I2 value, and then it changes to I3 value, and so forth. So as a time, function of time, the current is changing. It was I1, then suddenly it changed to I2, I3. I'm not talking about alternating current sine wave. I'm just keeping the thing simple as of now. So there is some power I1 square R, then I2 square R, then I3 square R. It is a fluctuating power. But let's say I would like to know how much should be the value of a constant current that I can provide that will be the same of this. So let's say I'm getting I1 square R, I2 square R, I3 square R. It's changing values of power. I would want to know what is the average of this, as in if there were a constant current, how much should that be the constant current? If this is 2, this is 1.9, this is 3.5, what should be a constant current that I can use? The case in point here would be I want to have basically DC current, maybe a constant current that I can compare. And this is coming from here. Let's see what I'm talking about. So let's say there is a bulb here, and then I apply a sinusoidal AC current. Now AC current, is fluctuating. It is fluctuating like this. So if this is the time axis and this is the current axis, let's say this is 4 amperes to minus 4 amperes. So you can see there is no power being delivered here, some power, maximum power, 4 square times the resistance. This is the bulb resistance. But then I have another one which is the direct current, and I would like to compare. I would say, okay, how much should be the value of current here, which is a constant current, time versus current? What should be the constant current here so that this bulb light is equal to this bulb light? Because remember, this bulb light is fluctuating. On an average, we don't see that because the fluctuation is very fast. But you realize this, the power is fluctuating. It is zero, something, something, more, then less. So I know the power is fluctuating here. I would like to compare this AC with this DC. So what should be the value of this? If the peak value was 4 here, do I supply 2 amperes here? It has to be less than 4. That is common sense because the maximum is 4 there. It has to be less than 4. But less than 4, is it 2? Is it 1? Is it 3.9? I don't know. And this is why I'm trying to find what should be the right parameter. Should I just divide that by 2, divide that by 3? So instead of starting with a sinusoidal wave, let's start with a simple kind of scenario here where the current is a step current here. It's not a curvy kind of, because that will make the things easier. So what is the average power you would get here? This power plus this power plus this power divided by the number of items over there. So you'll say, okay, the average power there, the average power here is I1 square R, that's the power here, plus I2 square R plus dot 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 up to IN square R divided by N. That's the average power here. So say, okay, now what about here? I want a constant one here, which should be like this. So what is the power here? That is I square R. I'll say, okay, that I square R, where that constant value should match this power. So, oh, this is the case. So then this R's, it's a no-brainer, this cross out. So I square is this much. So then how much is I? I comes out to be square root, because there's a square here, square root. And see why you should be taking the root mean square of that. So the point is, when the current is fluctuating current and you want to know one constant value that is like that, you don't take the averages of those currents. You don't say I1 plus I2 plus I3 divided by N. No, you don't do that. You actually would have to take RMS value, for the reason that power is proportional to I square. And that is why when you deal with current electricity, you're talking about RMS values. Right, so now back to this case. Now let's say this were 4. So then how much should this be? So I would like to find the RMS value, but this is changing value. I can use integrations. But let's say I don't know integration, or I don't want to use. I would like to go for simplicity. I don't want any integration. So let's see how I can do that. First of all, would you agree with me if I say that a sine wave average value is 0? Can we all say that the average of this is 0? Sine, not square. I'm saying sine. Average of a sine wave is 0. And similarly, the average of a cosine wave, which is cos wave, is also 0. Average of sine wave is 0. So average of cos wave is also 0. That part we agree on, right? But what about sine square? Sine square, I cannot say that. It is not 0. First of all, when you try to find sine square, they will shrink because this maximum value is 1, let's say. It will shrink like this, that's fine. But then this square, this is negative value, square of negative is positive. So you'll get something like this. So this blue one is sine square wave. The average is not 0. So how much is it? That's what I want to know. So let's understand with basic common sense here. So what would be the RMS value? So we know the current that we receive in a sine wave is I naught sine omega t, right? That's the current. So what will be the RMS value? First of all, let's understand some notations. So this means mean. If I'm writing this means average of marks. So you should know these tiny little notations. So let's say this time means you find the average of time taken for some event, maybe. Average of this means average of current. So that's what this notation means. So what will be IRMS? IRMS is going to be root mean square. So root of mean of squares. So I would like to find the mean of squares. So square of this, as in square of this. Right, so this is the root mean square. Now this I square, I naught square will, being a constant, will come out of this. So let's actually do that. Let's do that here to make it simple. So this will come out of this, and I can rewrite all this as I naught So all I have to do is to find the RMS value, I have to take the peak value, multiply with the RMS of this. So average of sine square omega t, square root of that. Now average of sine square omega t is not zero, we know that. But how much is it? Average of sine is zero. Average of cos is zero. But what about this? So can I convert this into a sine? Yes, I can do that. So again, you don't have to memorize all the trigonometric identities. You know what is cos A plus B? Cos A cos B minus sin A sin B. So what will be cos A plus A? That is cos 2A. Cos A minus sin A cos square A minus sin square A. So cos 2A will be cos square A minus sin square A. But sin square A plus cos square A is 1. So 1 minus sin square A minus sin. So 1 minus 2 sin square A. So let's write it that way. So I'm just trying to show you, don't memorize everything. You can just make these out. So cos 2A is same as this. So can I not make sine square into something like cos? If you rearrange all this, what you're getting here is I naught, the mean of, you rearrange all this. So this comes here 1 minus 2, 1 minus cos 2A by 2. Or you can distribute this 2, that will be easier for you. So this is by 2 by 2. Wow. Cos wave mean is 0, divide by 2 doesn't change anything, so the average of this thing is 0. And what is the average of half? It is half, obviously. This is 0, this is half, so all this average becomes half. Then you take the square root of that, 1 by root 2. So what we are getting here is IRMS is equal to the peak value divided by root 2. That's all. So going back to the example that we had taken earlier, so let's say I have a sinusoidal current where this is 4 amperes of peak value, 4 to minus 4 peak value. What should be the value that I should take here? So equivalent of this will be 4 divided by root 2. I don't think that was a good color choice, so let me change that, 4 divided by root 2. So an alternating sinusoidal current of 4 amperes peak value is same as 4 by root 2 of a constant current. So you don't take half of this, you divide by root 2. So RMS value is 1 by root 2 times of the peak value. It can be only in the case of sine wave, by the way. So all that calculation was done assuming your current is a sine wave. It doesn't work if your current is more like a sawtooth kind of this, or maybe rectangular thing. No, it doesn't work like this. For that you have to do other calculations. But if it is a sine wave, you just divide by root 2. So if this was easy, and like, share, subscribe to this video, let your friends know, and I'll be coming back with more such videos on this. By the way, if you want to subscribe to a paid course, we have launched Full Physics Mastery 2025, and also there is a course for 2024 going on. All the links are below here. You can take advantage of, and these are module wise, you can buy different modules. All the description is down there. What you need for this is high energy and high Josh. Everything else will be taken care of. And also you get a discount with BS Pro 1 coupon, 10% off with that. It's already applied here. And students have been getting gold medals, bronze, silver, all the medals. And I would like to see your picture here one day. So students, keep up the high Josh. See you very soon. Bye bye.